Hi, Form 3 girls. I'm Mr. Lu. I believe that you have submitted your assignment to your teacher. Some students told me that there are a few questions which are quite difficult in this assignment. Maybe I will discuss them with you in this video. But before we go into the question, let us review all the equations we have learned in this chapter. The first one is the average speed of an object, okay? How to calculate the average speed of an object? We use the total distance traveled by the object divided by the total time taken. And the second one is about the acceleration of an object. That means how the speed of an object change with time. And v is the final velocity, u is the initial speed, right? Okay, use the difference of these two speeds, the final speed minus the initial speed divided by the time taken will be the acceleration. That means how fast the speed of an object change. And for the last one is about the distance travel. The distance travel can be found out by using this formula. Okay, so you see that if you want to find the distance travel by an object, then you need to use the third equation. If you need to calculate the acceleration, then you may need to use the second equation. Okay, so there are two parts in this assignment. The first part is about the distance travel. Look at the question. Question 1. A greyhound accelerates along a straight line at 6.3 meter per second square. Accelerate, this one must be the acceleration A. Can you calculate the speed of the greyhound after it has accelerated from rest? Okay, from rest means the initial speed is 0 meter per second for 3 seconds. Okay, so there are two parts. The first part is asked you to calculate the speed, and the second part asks you to calculate the distance travel. Maybe we try the first part of this question first, okay? So look at all the quantity we have. We have the acceleration of the greyhound, the initial speed because it starts from rest, and the time taken is 3 seconds, okay? So can you find out the speed of the greyhound 3 seconds later? So which equation you will use? You have A, U, T, and V. So look at the equation. This should be the second equation. So the second equation, if you write down this one, the first step, and then you put the data into the equation. The acceleration is 6.3, and the final speed, I don't know the final speed of the greyhound, and the initial speed is 0. The time taken is 3 seconds. Then you can get the answer. It should be 18.9, right? But don't forget to write down the unit. Some students forgot to write down the unit in their answer, so they score no mark for this part. What is the unit for speed? Okay, you can copy it from here, okay? It should be meter per second, right? It is a complete answer, 18.9 meter per second. Okay, it is the first part of the equation of the question. For the second part of the question, you need to calculate the distance travel. That means S. So which equation you will use? So you have equation 1, equation 2, and equation 3. This should be the third equation. It helps us to calculate the distance travel by an object. So put all the data into the equation. The initial speed is 0, so you can ignore the first term. You don't need to write down anything. And then equals to half. And the acceleration is 6.3, and the time taken is 3 seconds. So you don't forget to write down the square, okay? So the value is 28.35, and the unit for distance travel should be meter, okay? So this is not quite difficult for question 1. Is it okay? So we go to question 2. Okay, go question 2. The question a bit long. Okay, Maria is 1.5 meter tall. She's standing under an apple tree. Okay, it is the apple tree. An apple which is 2.5 above the ground, right? Okay, so there are so many length, okay, 1.5 and 2.5, okay? So which one we should use? Okay, maybe we discuss the question now and then check it later. About the ground right over her falls down with an acceleration 9.81, okay? 9.81 is the acceleration. So can you find out the time taken, the t? It is the unknown. You need to find out the time taken for the apple to hit Maria. If the apple hit Maria, so, okay, the apple should be initially at rest because it is on the apple tree. And when it fall down, okay, and hit Maria, what should be the distance? Is it 2.5 or 1.5? Okay, look at the diagram. Okay, the apple is here when it falls and hit Maria's head. So what is the distance travel? The distance travel by the apple should be the difference between 2.5 minus 1.5. Is it okay? So it is the distance travel by the apple. Understand? And the initial speed of the apple is 0 because initially it is on the apple tree. And then half acceleration is 9.81 and you have to find out the time taken. Okay? Is it okay? So 2.5 minus 1.5 is 1 and then multiply 2 to the left hand side. 2 is equal to 9.81 times t squared. And then you divide 9.81 to the left hand side, then it will be equals to 0.204. And this is not the answer. It is equal to t squared. So you have to take the square root of 0.204 and which is equal to 0.452. Okay? And don't forget to write down the unit for time. It should be in second. Is it okay? So this question may be a bit difficult to find out the distance travel. It is not equals to 1.5 or 2.5. It is the difference between 2.5 and 1.5 because it is the distance travel by the apple. Is it okay? Okay, for question 3. For question 3, a car, Tesla Model 3, can reach 100 km per hour from rest, okay? So you have this value. This one is the speed, but the unit is a bit complicated, km per hour. You may have to do something to change it to meter per second, okay? And reach this speed, okay, from rest. So the initial speed is 0. And then it should be the final speed because the Tesla Model 3 start from rest, 0 meter per second, and then reach 100 km per hour. It will be the final speed of the Tesla Model 3. Is it okay? In 3.4 seconds, it will be the time taken for the car. Okay? So, can you find the acceleration? Okay, A. So you have V, U, T, and you have to find out the unknown A. So which equation you should use? Right, you should use the second equation. A equals to V minus U and then divided by T. And the question asks you to find the acceleration in meter per second square. So you have to change the final speed from km per hour to meter per second, in meter and in second, right? So the final speed, you can't write down 100 here. You should change it to meter. How can you change 100 km to m? Yeah, you have to multiply it by 1000. And how about hour? How can you change this quantity from hour to second? So 1 hour times 60 and times 60. Then this unit will be meter per second. Is it okay? So this fraction represents the final speed of the Tesla Model 3. And the initial speed of Tesla Model 3 is 0 and it accelerates for 3.4 seconds. Is it okay? It looks a bit complicated, but you can use your calculator to do all the calculation. 100 times 1000 and then divided by 60 and 60 again and then minus 0 and then divided by 3.4. then it is equal to 27.8 divided by 3.4, which is equal to 8.17. Okay, what should be the unit? This unit is meter per second square. Is it okay? Okay, it is for part A. And in part B, you have to estimate the distance traveled during the acceleration. Okay, that means how far the Tesla Model 3 travel during this 3.4 second. So you need to find out the distance travel, which equation you should use. So it should be the equation 3, the third equation, because this equation helps you to find out the distance travel. And then, do you have the initial speed? No, it is 0, so you can ignore the first term. And then half, the acceleration is the answer in part A, 8.17. And the time taken is 3.4 square. And then you can get the answer 47.2 meter. Is it okay? So this question is a bit complicated. You have to change the unit from km per hour to meter per second. Then the rest of them is not so difficult for you. Is it okay? Okay, question 4. Question 4. The question seems a bit long. A girl on a bicycle was cycling at 10 meter per second. That is the speed, okay, initially. Suddenly, saw a danger ahead. Oh, a danger ahead. So she react in 0.2 seconds. What does it mean? That means when she saw the danger, she can't react anything. And she can react after 0.2 seconds. To understand about this statement, she react in 0.2 seconds. That means when she saw the danger, she can see something but can't react. She has to respond. And how long will she take? How long did she take to respond for the act? It is 0.2 seconds. Understand? That means during this period, she does not apply the brake. She then apply the brake. Okay, it is another part. For the first part, she didn't apply the brake on the bicycle. And then she applied the brake, and the bicycle decelerate at 2 meter per second square. Decelerate. Be careful of this word, okay? 2 meter per second, and finally brought to stop. So there may be two parts of the motion. The first one is the yellow one, and the second one is she applied the brake, and then the bicycle decelerate, and then finally brought to stop. Understand? So there are two parts of the motion. The question asks you to find out the distance travel in the first 0.2 seconds. Okay, that means the yellow part, not the green part. Okay, the initial speed is 10, and the time taken is 0.2 during the first part of the motion. Can you find out the distance travel? We need one more information. So can you guess what information you have? Yeah, it is the acceleration, because just I told you before, she react after 0.2 seconds, and then she applied the brake. She didn't brake any in this 0.2 seconds, so the acceleration is 0. Is it okay? So if you have u, t, a, and you need to find the value of s, which equation you will use? So you will use the third equation, s equals to ut plus half at squared, and then put the data into the equation. The initial speed is 10, and the time taken is 0.2, and there is no acceleration, so you can ignore the second term on the right hand side. Okay, and 10 times 0.2 is 2 meter. That means she traveled for 2 meter and without doing anything. Afterwards, she applied the brake. Okay, so for part B, find the time taken. You have to find out the time for the bicycle to stop after she applied the brake. It also asks about the motion for the second part of the motion, the green part, right? She applied the brake. Okay, so how long what is the time taken for the bicycle to stop. So check what information you have, okay, and to find the time t. Okay, the deceleration is 2. So the initial speed is 10 also because the bicycle does not decelerate. Okay, so u is 10, and the deceleration is 2. It should be -2 because it is decelerate, slowing down. Okay, a is -2. Is it okay? And what else we have? And finally, brought to stop. Brought to stop, what does it mean? That means the final speed is equal to 0. Very good. Okay, so you can find out the initial speed is still 10 because before that she didn't apply any brake. Okay, so if you have V, A, U, and you need to find the value of t, which equation you will use? You should use the second equation. A equals to V minus U and then divided by t. The acceleration is -2. Okay, the minus sign because the bicycle decelerate. The final speed is 0 and the initial speed is 10. So can you find out the time taken? Is it okay? So you multiply t to the left hand side. It becomes -2t. 0 minus 10 is equal to -10. And then you divide -2 to the right hand side. T will becomes 5 seconds. Is it okay? So it is for the question 4. Okay, these are the question. Okay, there's last one. You have to find out the distance travel after she applies the brake, the green part again. Okay, so you have to find out the distance travel. Okay, so it is the only equation you have to find out the distance travel. I guess you have so many data, okay, from part A and part B. Okay, you can get the answer. The initial speed is 10 and the time taken is 5 and the deceleration is -2 and the time taken is 5. Okay, so if you have all this data and put them in the right place, then you can find out the value which is equal to 25 meter. Is it okay? So please pay attention to the question and then divide the motion into 2 parts. The first part is without any braking. For the second part, she applied the brake. Is it okay? So these are all questions in part A, the distance travel. And the rest is the question about free falling. Okay, the first question, you don't need to do any calculation. No numbers, no data in this question, okay? But ask you something, you have to give the reason. In daily life, a light object, okay, just like feather, usually fall more slowly than a heavy object. For example, a laptop or your mobile phone, okay, you can try drop a piece of paper, a light object, okay, from to the ground and drop your mobile phone to the ground. Which one will reach the ground first? You should be the mobile phone, but I think you won't do that. Okay, what is the main reason? Okay, what is the main reason? Do you still remember the video? Galileo, okay, had demonstrated a falling ball experiment in the Leaner Tower. He demonstrated that both balls fell to the ground at the same time. Okay, but in our daily experience, it is not the case. Do you know the reason why? Yeah, it is because of the air resistance. Because the air resistance have stronger effect on light object than on heavy object. Okay, so light object falls more slowly. If you can remove the air, then you should find that light object and heavy object fall at the same rate. They reach the ground at the same time. Okay, why our daily experience is not like that? Because air resistance has a stronger effect on light object. Okay, there's a video from the NASA. Okay, and taken by the BBC. Okay, you can have a look of it to check whether heavier object or light object falls faster.
This is NASA's Space Power Facility near Cleveland, Ohio, and it is the world's biggest vacuum chamber. It's used to test spacecraft in the conditions of outer space, and it does that by pumping out the 30 tons of air in this chamber until there are about 2 grams left. And it's kind of got an eccentric construction, which is part of its history. It was built in the 1960s as a nuclear test facility to test nuclear propulsion systems, and that meant that they built it out of aluminium to make the radiation easier to deal with. Aluminium is not the best thing, the strongest material to build a vacuum chamber out of. So they built an outer concrete skin, which is part radiation shielding and part an external pressure vessel, so this thing can take the force that's present on the outside when it's pumped out to the conditions of outer space. Galileo's experiment was simple. He took a heavy object and a light one and dropped them at the same time to see which fell fastest. Now in this case, the feathers fell to the ground at a slower rate than the bowling ball because of air resistance. So, in order to see the true nature of gravity, we have to remove the air. It takes 3 hours to pump out the 800,000 cubic feet of air from the chamber.
Okay, we dropped 2 millitorr in the last 30 minutes.
But once it's complete, there's a near perfect vacuum inside.
6104 manual, 10% open. Station 1, go for drop. PCV 30-1, pressure set point at 240 psi. We are go for drop.
10, 9, 8, 7, 6, 5, 4. Cameras on. 2, 1. Release.
Exact. They came down exactly the same. Wow.
Look.
Watch right there. Look at how they hit right there.
Exactly.
You're back on the side.
Exactly the same.
Feathers don't move, nothing. Look at that.
That's just brilliant. Isaac Newton would say that the ball and the feather fall because there's a force pulling them down, gravity. But Einstein imagined the scene very differently. The happiest thought of his life was this: the reason the bowling ball and the feather fall together is because they're not falling. They're standing still. There is no force acting on them at all. He reasoned that if you couldn't see the background, there'd be no way of knowing that the ball and the feathers were being accelerated towards the Earth. So he concluded they weren't.
Okay, this is the end of the video, okay, about which object will fall faster, okay. You see that if air is removed from the chamber, feather and the bowling ball falls at the same rate. Is it okay? So for the second equation, okay, a piece of concrete falls off from a height 40 meter, okay, from the ground. So you have the distance from an old building. Negate air resistance. So we do not need to consider the effect of air resistance. How long, okay, how long means the time does it take for the concrete to reach the ground, okay? It seems that you only have two values, but for we need to find out the unknown from an equation, we need two more values, okay? We need three data. So look at the question again. A piece of concrete falls off. What does it mean by falls off? That means it starts from rest, okay? So the initial speed of the concrete is 0, okay? And we need one more information. Okay, what information we have? Because it falls under the gravity, so the acceleration should be 9.81, no matter how the mass or the weight, heavier or light object it is, it falls at the same rate, the same acceleration, which is equal to 9.81, okay? So you have S, U, A, and you need to find the value of T. So which equation should use? Yeah, you should use the second equation, S equals to UT plus half AT squared. And then put all the data into the equation. U is 0, so you can ignore this term. And S is 40. And half the acceleration is 9.81. And then you can find out the time, okay? Multiply 2 to the left-hand side. 80 is equal to 9.81 T squared. And then divide 9.81 to the left-hand side, and then you got 8.15, and then take the square root. It is the time taken for the concrete to reach the ground, okay? And when it reach the ground from the 14-meter height, then what is the speed of the concrete when it reach the ground? You need to find out the value of, okay, V, okay? But you have to express in km per hour. This part may be a bit difficult, but I will tell you later, okay? You need to find the value of V, okay? So what other information you have? Okay, you can find out by using this equation, because you have the acceleration and you have the initial speed 0, and the time taken is 2.86. So you can make use of the second equation, right? So you put the data into the second into this equation. 9.81 equals to V minus 0, and then divided by 2.86, and then you got the answer 28.0. But this answer is in meter per second, not the required answer in km per hour. How can you change this one to km per hour? It is not difficult. Okay, if you need to change km to m, then you multiply it by 1000. On the contrary, if you need to change m to km, then you simply divide this one, 28, by 1000. So you change the unit from m to km. Is it okay? How about second to hour? Okay, if you need to change the unit from hour to second, you have to multiply 60 and 60 again, right? Change it to minute and then second. If you want to change from second to hour, okay, then you have to divide it by 60 and 60. Is it okay? Then you can make use of your calculator. 28 divided by 1000, and then divided by 1, and then this one, okay? Then you can get the answer 101 km per hour. Is it okay? So you need to know how to convert the unit one to another, okay, in both ways. Is it okay? It is for the question 2. For question 3, a stone fall vertically downward, okay? If the stone is fall vertically downward, it doesn't mean that the initial speed is 0. You throw something down, okay? There should be an initial speed, okay? And from a cliff which is 45 meter above the sea, So you have the distance, okay, it traveled by 45 meter. And you reach the sea after 2.5 seconds. So it is the time, okay? So can you find out the initial speed of the stone? Okay, that means the speed that the stone is flow, okay? Then what other information you have? You have the acceleration because it is free falling. So this value should be 9.81. The question will not give this one to you. You should know this value, okay, by yourself. So S, T, A, and then U. Then you need to use the third equation. S equals to UT plus half AT squared. And then the distance traveled is 45. And I don't know the value of U. And the time taken is 2.5 seconds. And the acceleration is 9.81 and the time is 2.5 square. Okay, then you can make use of calculator. 45 equals to 2.5 U plus 30.7, right? And this value is 30.7. You move 30.7 to the left hand side, it will becomes 14.3 and then equals to 2.5. Then U is equal to 5.74 meter per second. Is it okay? It is question 3. And for this one, okay, there's no numbers, okay, no data. You have to explain something, okay? A student claims that the acceleration of a free falling object increase as the object fall faster and faster. Is it the real case? No. Just from the video, okay, we know that every object fall at the same rate, okay, no matter whether it is a light object, a feather, or a heavy object, a bowling ball, they fall at the same rate. And this value is a constant. That means it doesn't change. It is always equals to 9.81 meter per second square on Earth, okay? So, explain whether this claim is correct or not. Okay, will it increase as the object fall faster and faster? I think the answer is no. No, the claim is incorrect, okay? It's not correct because it falls at a constant rate, okay? The object fall faster and faster because its speed is getting larger and larger, but not its acceleration. Its acceleration is a constant, which is equal to 9.81 meter per second square, no matter whether it is a light object or a heavy object. Is it okay? So, question 4 is similar to question 1. Okay, for question 5, okay. An apple falls from a tree, and this speed is, fall from a tree, okay. Just like the question we have in the first part, the apple from the tree should have a 0 initial speed. And this speed is equals to 9 meter per second. It is the final speed. That means initially it is 0, and then when it falls from a tree and reach the ground, the speed becomes 9 meter per second. Okay, so this one is the final speed. And then how long? How long means you need to find out the time. Okay, and just as in the previous question, you should know the acceleration is equal to 9.81. Okay, so you have U, V, A, and T. So which equation you should use? Right, the second equation. Right? Okay, you put the data into the equation 9.81, and I don't know the value of the final speed is 9, and the initial speed is 0. So the time taken can be found out by using this formula. Okay, you multiply t to the left hand side, it is equal to 9, and t is equal to 0.917 seconds. Is it okay? And for part B, when they start from 0 and then fall to the ground, and the final speed is 9.9 meter per second, so can you find out the height? Okay, the height, that means the distance traveled by the apple, okay, or the height of the apple before it falls. You have to find out the value of s. So which equation can help you to find out the value of s? Right, the third equation. S equals to ut plus half at squared. And I want to ask you, do you know the value of u? Yeah, it is equal to 0. How about the time? Okay, time is the answer in part A. How about the acceleration? This one is equal to 9.81. Okay, so if you have finished part A, then you can simply get the answer in part B. Okay, put the numbers into the equation. Okay, u is 0, so you can ignore the first term. Equals to half, acceleration is equal to 9.81, and the time taken is the answer in part A, 0.917 square. So the answer is equal to 4.13 meter. Is it okay? Okay, the question asks, a heavier apple fall from the same height. Explain whether its speed just before reaching the ground is the same as the lighter one. Okay, a heavier and a lighter one, will they fall with the same speed from the same height? The answer is yes. Yes. Objects of different mass fall with the same acceleration. They have the same acceleration, so when they fall from the same height, then they will have the same speed. Is it okay? So this question is similar to question 1 and question 4. Okay, it is about the acceleration. No matter whether it is heavier or lighter, they fall with the same rate, same acceleration. Okay, so if they fall from the same height, they should have the same speed. Is it okay? Okay, it is the last question. Okay, Sam throw and pass baseball up. Okay, this question is a bit tricky, and it reached the highest point in 2 seconds, just like this one. It is Sam. He throws a baseball up. Okay, let us throw the ball up. Okay, then it reached the highest point. It is the highest point in 2 seconds. Okay, and what is the speed when the ball leaves his hand? That means the question asks you about the speed when the ball leaves his hand. It means the initial speed of the ball. And can you tell me what is the final speed of the ball? I'm going to find out the initial speed of the ball, but can you tell me the final speed of the ball? Okay, I have explained this one in the previous assignment. When the ball reaches the highest point, the highest, okay, then its speed will be equal to 0. Okay, why? Because if it is not equal to 0, then it will move again, then it is not the highest point. Then when it moves to the highest point, then its speed must be equal to 0. Is it okay? So you have the final speed, which is equal to 0 at the highest point. Is it okay? And the initial speed of the ball is not equal to 0 because Sam throw it up, okay? And finally, it becomes 0. And what is the value of is the ball slowing down or speeding up? Obviously, it is slowing down. So the acceleration is not equal to 9.81. It should be equal to minus 9.81 because the ball is decelerating. The ball is slowing down. Okay, so you need to add a minus sign. Okay, in this number. Is it okay? This is the most tricky part in this question. Okay, if you add a minus sign in the acceleration, you have t, v, and a, and you have to find out the value of u. Then which equation you will use? You should use the second equation. Okay, the acceleration is minus 9.81, and the final speed is 0. I'm going to find out the initial speed, and the time taken is 2. Is it okay? Then you multiply 2 to the left hand side, which is equal to 19.62, and 0 minus u is equal to minus u, and then u will be equals to 19.62 meter per second. Is it okay? Okay, these are all the questions in assignment 3. I hope after watching this video, you have a better understanding of all these questions and enjoy learning physics. Okay, thank you for your watching. Okay, bye bye.